Okay, welcome to the third lesson of the measurements unit for the 2P math class. I hope you are doing well. Today we are going to look at cylinders. You've probably looked at cylinders before. Again, we're going to be able to focus on finding the surface area and volume of cylinders. And we're going to use a variety of imperial measurements as well as metric measurements, as this is part of this unit as well in grade 10. Okay, so you can imagine that cylinders are similar to prisms in that they have a circular base and a rectangular side if you were to unfold them. And here's a bunch of examples of cylinders you might see in everyday life, from pop cans to canned vegetables and fruit. You can think of light poles outside, anything really that's a cylinder. So let's take a look of how to find the volume and surface area. So you can imagine a cylinder is an object that has two circles on the top and bottom and then a rectangular side. And I'll show that how that works once we get to the surface area. So remember, just a couple of reminders of terms having to do with circles. The radius is the distance halfway across a circle, and that's going to be in our equations. And on another reminder, it's going to come up later. The diameter goes all the way across the circle. So if we have a circular bottom and top, we can find the area of that, and then we have the height of the cylinder. So the volume equation is very similar to prisms, right? You can think of this as a prism. It has a circular base and one rectangular side. So the area of the base times height gives us the volume in prisms. So the area of the base, if you remember from math classes years past, the area of a circle is pi times r squared. So pi is 3.14. If you don't have that button on your calculator, you can just use 3.14. And then r squared just means r times r, and then you multiply it by h to find the volume. Surface area, if we draw the net of this, so we unroll it, you can see that we have circles on the top, on the bottom, and then if we unwrap the center part, it becomes a rectangle. You can think of that as taking a label off of a soup can or something. You'll notice that it's actually a rectangular shape. So to find the surface area of this object, we need to find the surface area of the two circles. Well, we know the area of each circle is pi times r squared. How do we find the area of this rectangle? Well, we know the height is h, but what about this distance? Well, if you look closely, you can see because this part has to wrap all the way around the circle, we need to figure out what that distance is. The distance around a circle is called the circumference, and the circumference of a circle is found by multiplying 2 pi times r. So if we put these together, the surface area equation is we have two circles and one rectangle. The area of each circle is pi r squared, but we have two of them, so it becomes 2 pi r squared. And the area of the rectangle is h times 2 pi r, and so we'll write it as 2 pi r h, just so it looks similar to the first one. Okay, so there are our equations for our volume and surface area. So let's do an example. Let's find the volume of this guy. Here's a cylinder. It has a radius of 10 meters, a circular base, and its height is 20 meters. So this is a big thing. Maybe it's like a grain silo or something. It's quite large. So our volume equation is pi r squared times h. So that's pi times our radius is 10 meters, and we're going to square that, and then our h is 20. Um, if you want to use your button, your pi button on your calculator, you can. It has infinite decimal places, but if you just want to use 3.14, you can. So I put that in for pi. 10 squared is 10 times 10, which is 100, and then we're going to multiply that by 20. So if I put into my calculator 3.14 times 100 times 20, I get 6,280, and it's going to be meters cubed, remember, because we've got meters times another meter. So we have three dimensions, right? If you use your pi button, it won't be this exactly. It'll be around this, but it'll be a little different because you'll have different decimal places. Okay, so that's how you find the volume of a cylinder. What if you're not given the diagram? Well, this one has a height of 14.3 feet and a diameter of 3.8 feet. Well, we're going to use our same equation. So let's write down our equation first. Now, we're not told what the radius is, but remember that the diameter is 2 times the radius. So that means our radius is going to be 3.8 divided by 2. So if I do 3.8 divided by 2, I get 1.9 meters. So that's going to be squared, and then we can multiply by the height. If we put 3.14 times 3.61, because 1.9 squared is 3.61, times 14.3. If I put those three numbers into my calculator, multiplying them, I get 162.1 feet cubed. So you should get about that answer. It'll depend how you rounded things through here, so it should be fairly close to that. Don't worry if it's exactly the same. Okay, let's do a couple surface area examples then. Let's see, we have a smaller cylinder here. This one has a radius of 17 centimeters and a height of 89 centimeters. So remember the surface area equation is 2 pi r squared because that takes care of the circle on the top and the circle on the bottom. And then to find the area of the side here, it's 2pi r times the height. So let's put in our numbers then. 3.14 for pi, 17 for r, don't forget that's squared, 3.14 for pi again, r is 17, and h is 89. So let's do each of these separately. So if I put these into my calculator, I get 1,814 centimeters squared, right? Because we have two dimensions, it's area, so it's two-dimensional. And if I put these in, I get 9,596 centimeters squared. And my last step is to add these together to get my total. 11,410 centimeters squared is the surface area of this cylinder. Okay, let's take a look at this example. It says find the area of a soup can label for a can with a height of 22 centimeters and a diameter of 16 centimeters. Well, don't forget this is our net, right? So let's take a look. Our surface area of equation for a cylinder is this. But don't forget, if you're asked to find just the label only covers the side. The label does not cover the top and bottom of the can. So that means we can get rid of this first part and the surface area becomes 2 pi r times h. Now, we're told what the diameter of the circle was. So remember, the radius is the diameter divided by 2. So we're going to put in our numbers then. So 2 times pi, which is 3.14. Our radius is 8 because we had to divide 16 by 2 to get our radius. And then our height, we're told, is 22. So now we can put those into our calculator, multiplying all of them together. You should get 1,105 centimeters squared. Okay. So therefore, because this is a word problem, the area of the soup can label is 1,105 centimeters squared. So those are examples how to find surface area. I have put some practice sheets on Brightspace. They're called 5.3, and there's a volume one and a surface area one. And the solutions are included on the second page of each handout. Once you're feeling comfortable with that, you can go ahead and try the 5.3 quiz that's posted on Brightspace. So that is it for today, and I will see you next time. We'll be doing cones. Okay, bye bye.